Hello and welcome to another exciting breakfast with Unity. I'm your host, Max Moreau, and today we're going to be working more on our raycast gun and adding bullet spread to it. So there's actually something else I want to add first because we forgot to do it last time. So we have this variable called fire delay, but we're actually not using it for anything. We also have this ready for fire. We're using it for something, but it's always true. Hold on one second, guys. Sorry about this. I have to let my dog in here so that she doesn't scratch at the door. Come on, get in here. There, sit there. Alright, sorry about that. So, the joys of broadcasting from home. So, where was I? So, raycast gun. We have this fire delay, but we're not actually using it. So, let's fix that real quick. So, what we're going to do is we're going to add, a couple lines here. We're going to do fire delay, ready fire equals false. And we're going to run invoke what should I call it? It's called fire delay invoke reset fire set ready to fire is what I'm going to call. And then what we're going to do is give it a delay of fire delay, and then we're going to quickly create a void set ready to fire, and just say what we're going to do is ready to fire equals true. So now if we shoot really fast, it's already set really low, so this shouldn't make, oh wait, this isn't the project. Hold on. I mean, it's the project, but it's not the scene. Come on, computer. Alright. There we go. Back to this thing. So now if I shoot really fast, you can see that I only get like one effect. So there is a maximum speed I can fire. But today we're going to be doing bullet spread, and so I'm actually going to change this to be an automatic weapon. It's amazingly simple to switch this to an automatic weapon. As a matter of fact, I'm going to keep a comment here just in case we want it. Get button down for semi-auto. Get button for automatic fire. So we're going to just switch get button to get button, get button down to get button. So if we hit save and hit play, we should get a nice little stream of bullets. There we go. There's a stream of bullets. But as you can see, they're perfect. They always hit the same spot no matter what. The only reason that there looks like there's any spread at all is just because these particles are big enough to make it look like the hole's big. But they're actually coming from a single point wherever we go. So, so we're going to change that. We're going to make it so that there's actually bullet spread on this thing. So there's a few different ways we can do this. I've done a few different ones in the past. There's some that are slightly, quote-unquote, more expensive or less expensive than others. The one I'm going to use here is pretty cheap, and it does a good job. So we'll see how this goes. I think it does a good job at least. We'll see how this looks. So let's create. Let's go ahead and create a couple more variables here. Let's do public float. Public float. Max. Let's see. What are we calling it? Bullet spread. Max bullet spread angle equals, let's default this to 15 degrees. It's probably too much, actually. And this will actually be 30 degrees ultimately. This is the angle off center, not the angle between the two. So this is a 30-degree firing cone. It's not always going to be 30 degrees, though that's what we're going to do initially here to test it out. So we're going to do always 30 degrees first. Or not always 30 degrees, but always within that first. So let's see how this will work. So right now we're doing a physics raycast out transform dot position and transform dot forward. We're going to change this. So we're going to calculate where our forward separately. So what we will do, oh, it wants a raycast, that's right. It doesn't care about the rotation. Anyway, this will still work. So we are going to set up a variable called vector3 fire direction. And we're going to set this to be, we want to get this randomly angled in any direction, but with a set amount towards that angle. So what I'm going to use is I'm going to use a couple quaternion tools to actually do this. So we're going to have a, we're going to quaternion. I'm going to break this down so that we can see how it works. So fire directions, we're going to have a quaternion fire rotation, which is slightly different. It's not a vector, it's a quaternion describing the same thing. So fire rotation is going to equal, let's actually go fire direction right now equals transform dot forward. We may reorganize this in a second, but I just want to work it through. So quaternion fire rotation is going to equal quaternion dot look rotation fire direction. So now we have a rotation that represents that fire direction. So so now what we're going to do is we're going to offset that rotation somehow. So we can get a random rotation, quaternion random rotation. This is very simple. Random already has this built in. So random dot rotation. And you might want rotation or rotation uniform. I actually don't know exactly what the difference between these two is. I'm just going to use standard rotation. It should be fine enough for what we're doing. So we have a fire direction, we have a fire rotation, we have this now random rotation. And so what we're going to do is we're going to rotate towards this random rotation. So I'm going to do fire rotation equals quaternion dot rotate towards, and we're going to rotate it towards the we're going to rotate our fire rotation towards random direct rotation. And then the max degrees delta, this is where we're going to put our bullet spread in. And so what I'm going to do is I'm going to do random dot range 0.0f and max bullet spread angle. And so now instead of using transform.forward here, we will use fire rotation dot how do we get a, I forget, Euler angles. There we go. There we go. Fire rotation, Euler angles. So let's see if this works. Let's see if this works at all like we expect. So if we hit play, well, unexpected symbol, what did I miss? Missed a bracket. Come on, go away. Alright, a paren. Missed a closing paren. Alright. Oh, still one more. Transform does not exist. Oh, yeah, so this transform... Wait. Oh, transform.forward. Yeah, let's do transform.forward. Save. Alright. Play. Let's see if this works. Ooh, it looks like it's totally not working. So, look rotation, fire rotation. Oh, this is not going to work. Okay, so what we want is the, so fire rotation, dot, okay, I'm going to actually look this up online real quick. To the Googles. All right. Where am I going to? I'm going to search for convert quaternion to vector direction. Alright. So we could just multiply the quaternion by vector 3 dot forward. Alright, let's try that. So we're going to do fire rotation times vector 3, oops, lost my time somehow, dot forward. Let's see if that works. Save, play. Yay! It's working. So there we go. We have bullet spread, and we can tighten that up. We could go to our where is this thing? Do I have a particle cleanup script yet? Particles. No, I don't. Okay, whatever. So what we're going to do is we're going to go to our first-person controller. We're going to go into his camera, which is where the script is. Raycast gun. I'm going to decrease this angle to 6 degrees, and we're going to hit play. We're going to see how this looks. Sweet. We have random fire. Yay! Hooray! So so now let's make it so that it actually spreads over time. So public float time till max spread angle, and let's default this to 1.0 f. And so we're going to hit save. And so what we're going to do now is we're going to have a separate variable in here called private float fire time. And what we're going to do is fire time is going to go up. This isn't going to be perfect, but this will work for our purposes. So I'm going to actually move ready to fire down a level. Ready to fire. So if ready to fire, then we do all this stuff. And the reason I'm going to do that is now I can use the else case for this if statement to know that we're not pressing the button down. So we're pressing the button down, we're not pressing the button down. So at this point we can reset fire time equals 0.0f. Otherwise, fire time plus equals, and we want this outside of ready to fire. This should happen anyway. Time dot delta time. So this is incrementing our fire timer. And then what we're going to do is in here, instead of using random.range max bullet spread angle, we're going to do one more thing here. Float max current spread equals, and this is going to just simply be max bullet spread angle, and actually we're going to do a lerp. So mathf, linear interpolation, mathf dot lerp. We want to go from 0.0f, we want to go to max bullet spread angle, and we want the time to be, actually we could have just multiplied this in, but it doesn't matter. The time will be fire time divided by time till max spread angle. Alright. So yeah, and so now instead of using max spread angle here, we're going to use current spread. So if we hit save and hit play, We get some accuracy, and then it degrades. Perfect. So let's actually make let's make this 2, and let's make the max angle 30 or 15, so we can see this more dramatically. It's looking good, looking worse, and looking real good, looking real bad. So perfect. If we stop firing, it gets accurate again. So you can kind of do like burst fire, and you're accurate. But if you take time, it spreads out. Yay. So let's go ahead and save that. Let's call that good. I like how that turned out, actually. So thank you very much for joining us. If you have any questions, please email me, pushypixels@pushypixels.com. You can also tweet me at Drakfyre. That's DRAKFYRE. And yeah. So if you can, please donate to Patreon, patreon.com/cookingwithunity. Really appreciate it. And it's my birthday, though I guess that shouldn't matter, but it is. So happy birthday to me. So see you guys around.